Okay, so we're going to go ahead and get started with our part two. This is what we call the enhanced Fujita scale. And back in the early 2000s, I think 2005, 2007, somewhere in that range, we got a new Fujita scale. And at that point, we had some physicists within NOAA went back to the drawing board with some research meteorologists, and they decided to remake the Fujita scale in a way that didn't consider the damage that a tornado would produce simply by classifying wind. It tried to classify it by what we call damage indicators. So what kind of damage would that wind do? And in that way, the Fujita scale, the new Fujita scale, the enhanced Fujita scale, considers damage more than wind itself. So we have upwards of 100 plus damage indicators that we use on our tornado surveys to classify the damage of a tornado. So from EF0, ascending levels of damage, from EF0 to EF5. So EF0 up to 85 miles per hour, minor damage. Typically, that'll be more along the lines of some tree damage, some minor structural damage, and that will tend to be the lower end of our scale. As we get towards the higher end, and I did see a couple questions pop in. I will get to those at the end. I apologize for that, but I will go ahead and grab those at the end. As we get into EF3, EF4, we have severe and extreme damage, and then EF5 is incredible damage. So basically, you're ascending your levels of damage as you go up, and at that point, you're basically quantifying the amount of damage within a tornado track. Okay, so with that said, we will talk about the wall cloud. And whereas the straight line wind goes to a shelf cloud with respect to what's bringing that damage, the tornado is going to be coming from the wall cloud. The wall cloud is an isolated lowering of the cloud base. That's going to be at the base of the updraft. So when the updraft is ingesting that rain-cooled air that's coming out of our thunderstorm, that's going to basically be inflow for our thunderstorms. And that rotating wall cloud is going to be an indication of that damage, or is going to be an indication of that rotation, I should say. So when the updraft is accompanied with that rotation, we say to watch for tornadic damage at that point, or watch for a tornado at that point. So as we see the wall cloud coming in at the base of the updraft, which is right here, if the wall cloud is is rotating, assume that the updraft is as well. So we have our inflow coming in from the left. We have our outflow coming around from the right, and the net is going to be a counterclockwise spin, and the vast majority of the time, 95% plus of the time, your rotation is going to be counterclockwise with these tornadoes in the northern hemisphere. So as these tornadoes come in, you're going to see the tornado emerging from the bottom of our funnel at the bottom there. And the updraft is going to be a portion of, or an artifact of that inflow. So you think about our inflow going straight up into our thunderstorm, the updraft is going to be going, let me get my pen back there. Your updraft is going to be going up into our thunderstorm, and you're going to see the anvil go out this way. So as our updraft hits our equilibrium level and diffuses outward, you're going to start to get the anvil emerge at the top of our storm. And we're going to talk about the significance of that. So let's put this in motion. And again, you can see that counterclockwise rotation that's showing you that that funnel cloud and that wall cloud making its way down towards the ground. And you will eventually see a tornado start to pop out toward the bottom. So the keys to spotting wall clouds for your spotting purposes. Number one, this video is going to keep moving. So you're going to see sustained upward motion. So you're going to start to see these clouds start to develop. You need that motion to be sustained or continued for 5 to 10 minutes at a time when you're watching these storms develop. So is the feature persistent, first off? Second, is it attached to the thunderstorm base? They are not, while they were not at the beginning, they are becoming attached to the thunderstorm base as you watch this video unfold. Second, we have a vertical axis of rotation. Now, we talked about the shelf cloud being horizontal in aerial coverage. It's not going to be in that plane here. In the wall cloud, we're looking for vertical axis of rotation. So you're going to be looking for kind of like the rotation of a spring going upwards on the vertical. So your air is going straight up into our storm. So the shelf versus the wall cloud, the differences here. The shelf cloud is going to be sloping away from the precipitation. So it's going to be indicating outflow. So air is coming out of our thunderstorm. So that's basically our storm breathing out, if you will. So air coming out and downdraft. On the wall cloud side, we're going to be sloping towards the precipitation. We've got our airflow coming in. So our airflow is going towards our thunderstorm. And that's going to be updraft going into our thunderstorm. So the funnel cloud is going to be a sorry about that. The funnel cloud is going to be a rotating funnel-shaped cloud coming out of our thunderstorm base, often from a wall cloud. So you're going to start to see a little funnel start to emerge from our wall cloud. It's going to be attached to the thunderstorm base, and it will not be in any way impacting the ground at this point. Like you see in this picture, there could be some laminar or smooth-looking clouds with respect to the funnel cloud. The fancy meteorological term is a striation or striations, and that's just really wood, like you would see with wood with a sandpaper. You're kind of having wind sand that funnel cloud down, so it looks smooth. So the wind is actually smoothing out that funnel cloud and making it look smooth. And as a result of that, you've kind of got a real smooth or laminar look to our clouds as it starts to make its way down toward the ground. As far as the tornado goes, the tornado is a rapidly rotating column of air that is in contact with the cloud base and the ground. So whereas the funnel cloud is not in contact with the ground, the tornado is. So we may not have visible funnel clouds right away. So in terms of spotting tornadoes, don't key in on the condensation funnel, because the condensation funnel is going to be likely the last thing you see with the tornado developing. So you're going to always see the rapid rotation if you're seeing it up close. So like you see here, you're going to see some evidence of damage on the ground with the tornado. That could be debris, dirt, siding, trees getting kicked up, any combination of things that could get kicked up. But the condensation funnel is going to be the last thing that gets filled in. So if you're waiting for that spout to develop from the tornado, you might be waiting a couple of extra seconds, which is a couple of extra seconds that you're waiting for that tornado to develop. So seeing that damage, sorry about that. Seeing that damage kind of tells you that you're looking at a tornado at that point. And it might be something like you see in this picture here, where you just have that funnel slowly making its way down toward the ground. So that smooth appearance that we talked about, that implies rotation. So a laminar or a striation look to the clouds is likely a funnel cloud or a tornado. And some tornadoes can be rope-like or very skinny. And it can create very similar damage in terms of the damage path. It can create damage just like another tornado can. Also, bear in mind that sometimes the tornadoes are not going to be the prettiest things in the world in terms of what you're looking at. So they might be just kind of ragged looking. The vertical motion might be kind of chaotic, but the rotation is going to be there. So in terms of making an impact on the ground, if you see something like this, where you are creating some degree of damage on the ground in terms of kicking up debris, kicking up tree limbs, or kicking up something from the ground, that is a tornado, just as much as any of the others that you've seen here. So it might not be the prettiest thing in the world, but if it is producing damage, it is a tornado. Now, the next piece is with respect to scud clouds. We call them, the non-technical term is a scary looking cloud. And really, if you're looking at these clouds and they're not doing much of anything, they're not rotating, they're not moving around, they're not showing any upward motion at all, it's not a funnel cloud. It's not a tornado. It's just kind of what we call scud clouds. And these are a good example of scud clouds. As you can see, they're just kind of sitting there. Not really doing much of anything. If you were to call these in as a tornado, the first question we're going to ask is, do you see rotation? In this case, you clearly do not. So this is something we would say, keep an eye on it. Make sure you're monitoring, and if you see these clouds start to show some upward motion or show some signs of rotation, by all means, let us know again. But this is something that is really in and of itself pretty benign, pretty harmless in terms of spotting and in terms of spotting itself. So in that same way, in terms of watching a storm evolve quickly, that rapid rotation or rapid movement with respect to our clouds coming in indicates a tornado. So if a rotation can't be detected, watch for rapid changes, because those rapid changes are going to be what tells the tale there. So in terms of squall lines, the issue with squall lines and tornadoes is you can get tornadoes from squall lines. We call them QLCS, or quasi-linear convective systems. Typically what happens with the squall line tornadoes, number one, they're going to be weak because they don't have the same amount of instability, and they typically will not have the strong updrafts available to produce the really large tornadoes. However, there is usually enough shear present to develop tornadoes. And in some cases, you can get EF1, EF2 stronger tornadoes from the squall line. However, the problem with the squall line is, the second issue is that they're going to be what's called rain wrapped. And if you think about the line of storms that comes through within a squall line, you just get heavy rainfall. And within that squall line, you're basically going to have a circulation that's obscured by that heavy rainfall. So they're going to be very difficult to spot, almost impossible, really. And as a result of that, they're really going to be a very limited amount of time that you'll have to get to a place of safety. So when that tornado warning is issued, go ahead and please trust that warning is out there. Trust that polygon that's issued, because that's something that's being issued from our meteorologists to let you know that there is a tornadic circulation present. Either we are seeing something on the radar that is suspicious, or you've had a spotter like yourself that's called in and told of what they've seen come as this storm comes through their community. So again, when that warning is issued, if a tornado warning is issued and you don't see it, you don't have visual confirmation of it, go ahead and get to your safe place, because that's something that you don't want to waste time with something like this, because in terms of waiting for visual confirmation, with respect to these squall line tornadoes, you're not going to have a whole lot of time to watch the storm come through and evolve, because you're just going to have the rain obscuring your view for a lot of that time. So this is a rain-wrapped tornado on the Chesapeake Bay. And initially, it just kind of looks like a mess of clouds on the bay. But as this video evolves, you're going to start to see the tornado become more and more clear and well-defined. And there it is. And that's something where, again, you'll watch the line of storms come through, and then after a while, once it gets up on you, you're going to say, hey, there's a tornado in there. And by that time, you've got that much less time to get to a place of safety. So by all means, please trust that warning that's out there. Get into a place of safety, and we'll talk about getting to a place of safety and where those places are as we get into it here. So in terms of certainty, what do you do when it's not a clear-cut situation with respect to what it is you're seeing? Go ahead and report it anyway. It's better safe than sorry. Let us know what it is you're seeing. Don't make assumptions. Instead of saying, I see a funnel cloud, say something along the lines of, I see a possible funnel cloud, because it's attached to the thunderstorm base. It's been kind of consistent, and it's farther away. I can't see movement, or I can't see rotation. Guys, we live here too. We know the tree line is a massive pain in the butt from a spotting perspective. We get it. So let us know what you see. I would rather have half of a report than have you doubt what it is you're seeing and decide not to report. I'd rather get something than nothing. So folks think of our operations area, and they tend to think we have this big, expansive operations area with a bunch of folks hanging around and lots of folks working on the weather and lots of extra resources. And yeah, no, that's not the case at all. What we do have is a team of 2 to 4 meteorologists. We can get up to 10 at a time in some rare instances. But in most cases, we're only going to have a handful of folks answering the phones. So time is going to be of the essence. So please don't be offended. Please don't be put off if we take your call and move on to the next person. We're not trying to hurt your feelings. We're not saying we don't want to hear from you. We are saying that, sometimes when the going gets tough, we have to move pretty quick. So by all means, let us know what you have. Let us know what you see. And please give us information if you have it. We do offer tours. Hopefully we'll be able to open up the tours at some point soon. Go ahead and check out our programs tab on our webpage for more information, and we can get you on the waiting list. So reporting. So starting with the basics, identify yourself as a spotter. If you have a SKYWARN ID, like if you're taking this course again, you don't need to memorize your ID. We no longer assign IDs as a result of just our decision to no longer assign IDs. But we are going to give you your spotter information with an email after this class. We're going to send you something just to let you know that you've been added to our network. When you do report, and we hope you do, give us your location as best you can. 5 miles west of City A, so 5 west of Chesterfield, or 5 west of Chesapeake, or 2 south of Moyock, or whatever it is. If you're an amateur radio person, or if you do happen to know your latitude, longitude, that's great. You are going to save me a step if you do that, but it's not required. I'm not going to yell at you if you don't know. But it's great if you have it. If you don't, near the intersection of Route X and Road Y, that's perfectly fine if you don't have that other information. Just try to be as specific as you possibly can and give us as much specificity in your report as you possibly can. If you're observing a specific cloud feature, try to figure out which direction you're looking. Most phones have the ability to download a compass. So from the Google Play Store or App Store or whatever you're looking at, you are able to download a compass application. And then if you use that, try to figure out which direction you're looking, because that'll help us out a lot. If you are keeping track of a lengthy report or an ongoing report, try to keep an eye on the start and end time, if at all possible. As far as what to report, we have a list of handouts that we will circulate, but certainly tornadoes, funnel clouds, wall clouds, persistent rotation, hail larger than, say, pea size. If you have a lot of pea size hail, report that too. Tree damage, folks, down trees are damage. Many is the time we'll ask and call around for reports and ask folks if you've had damage, and they'll say, no, just a couple of trees knocked down. A tree down is damage. So if you have a tree down, that's damage. If you see some large tree limbs down, either on your property, or if you see some trees down on the way home from school or work or wherever you're coming from, let us know about that. Flood-related damage, thunderstorm-related damage, greater than 1 inch of rain measured in an hour, water over the roadways. All of those things are important to report. And in terms of lightning, you don't need to report lightning. If you have a injury or a significant amount of damage from lightning, go ahead and let emergency services know about that. If you do have an injury, you might want to let us know, but otherwise, there's really no need to report about lightning. We do know the lightning is out there. Also bear in mind, if you are going to report something significant, bear in mind we're probably going to want your contact info so we can follow up with you after. Hopefully that's okay. In terms of hail, again, try to relate it to the size of a coin or a ball. So penny size hail, quarter size hail, golf ball, baseball, tennis ball, anything like that. Something that's recognizable universally. Marble-sized hail is very difficult to keep an eye on, or not quite sure what it actually is. It's kind of ambiguous. So try not to report marble size. We don't know what kind of marble you're referring to. So try to report based on one of those things. And also report the largest hailstone that you see. So if you have a bunch of pennies and a few quarters, go ahead and report the quarters. In terms of wind, realize that wind estimates are difficult, even for professionals. So wind estimates are hard. We get it. But severe wind is equal to damage. So if you do have damage from trees getting knocked down, that is a severe weather report by definition. If you have a personal weather station, those are going to be preferred. Those wind speeds from there are going to be preferred because they are measured. And in terms of determining what the winds are, again, those are going to be difficult. So just try to report what you see. Here's the reporting reference sheet. And by the time you get upwards of the structural damage and shingles getting blown off the roof or tree damage, that's the kind of severe damage we're talking about in terms of significant damage that gets done. And this is the screen you'd might want to take a picture of and or throw this number into your phone, 757-899-2415. Those are for severe weather reports only, please. If you are going to ask a question about climatology, or if you want to just ask a question about the forecast, we're happy to talk to you. Just call our regular office number, and we can talk with you on that line there. This number is going to be for severe weather reports only. Amateur radio is also available, wx4akq.org. We're going to have a slide about that in a moment, but that's the amateur radio slide, or amateur radio folks. Social media, please like us on Facebook or Twitter if you haven't already done so. If you're on either of those, we provide information on both of those mediums, and we can get information out that way, and you can talk to us that way. And then email. Feel free to send us pictures, damage, cloud features, questions, akq-report@noaa.gov. Please, if you have an urgent report, try to call us. If not, use the amateur radio. do something that way. We can get in touch with you that way. So, does the lack of spotter reports mean the conditions aren't bad? We have a bunch of those in the swamp, but not necessarily. We don't cold call people, so you're not going to hear from us a lot of the time because our warning operations take precedence, and we don't know where you are. You might be away from the house. You might be not paying attention to the weather for whatever reason. We're not going to cold call for the most part, unless we're really, really looking for more information. So for the most part, we really want you guys to give us a call and let us know what you see. Again, you help us save lives, and we really appreciate any help you can provide us. So our amateur radio folks are at wx4akq.org. That is your one-stop shop for all things amateur radio. So your net control contact points and frequencies are there. Details on any local training that they've got coming, and training resources are going to be made available from there. And a picture is going to be worth 1,000 words. Please go ahead and send whatever photo and video you have via email at akq-report@noaa.gov or submit to Facebook or Twitter. Please let us know that you're a spotter, as that's going to add a little extra weight to your report when you send that to us. Thank you.